late 80s. Okay, 8.5, trapezoids and kites. So 8.4, we talked about parallelogram, well, rhombuses, squares, and rectangles. So now we're going to talk about trapezoids and kites. So this is a lot of information about quadrilaterals that you're going to have to keep separate and remember, and all their properties, okay? So definition of a trapezoid: a quadrilateral with exactly one pair of parallel sides called the bases. So this guy and this guy are parallel, so I can put that symbol in on them. And we call those the bases. They don't always have to be the top and bottom. It could be rotated, and they're still called the bases. And then we have one pair of non-parallel lines, and we call those the legs. So these are my legs, and they're not parallel. Definition of a right trapezoid is a trapezoid with two right angles. So these two would be right. They add up to 180. How many degrees are in a quadrilateral? 360. So that would leave 180 degrees, sorry, for these two. So they are supplementary. Definition of an isosceles trapezoid is a trapezoid which its legs are congruent. So this is still parallel to this, just this is equal to that in length. If a trapezoid is isosceles, then its base angles are congruent. So it's saying this guy is congruent to this guy. If a trapezoid's base angles are congruent, then it is isosceles, so the converse of that. So if I know some trapezoid has base angles that are equal, then that would tell me that the sides or the legs are also congruent. Guys, if these two angles are congruent, what's going to be true about A and B? Angle A and angle B. They will also be congruent. If a trapezoid is isosceles, then its diagonals are congruent. And then this B equals this, and this equals this. Excuse me. Be careful on how I drew that, guys, right? But then that whole segment A to C is also going to be congruent to the segment B to D is what they were saying. But when we put the diagonals in, they cross at a point in which these two are congruent to these, and these two are congruent to each other. And then the last one, the mid-segment of a trapezoid. So mid-segment is the segment that cuts the trapezoid's legs in half. So this is going to be congruent to this, and this is congruent to this. This does not mean that this guy, B to X, is congruent to C to Y. The only time that that would happen is if it was an isosceles trapezoid. Otherwise, that doesn't mean that those are equal. The mid-segment of the trapezoid is equal to the average of its two bases. So, like, for instance, let's say I had length of 6 up there and length of 7. What would the mid-segment's length be? 6.5. Go again. Oh, I said 7 but wrote 8. I'm sorry. Yes, it would have been 6.5 had I actually wrote what I said. I was thinking the answer in my head. 6 and 8. What's the mid-segment? There we go. Sorry, that was my fault. So you add them and divide by 2 is essentially what you're doing to get that mid-segment length. You take your top plus your bottom, divide by 2. You're finding an average. That's also called what when you're finding that of a set of data? Your mean. Okay, number 1, find the value of each unknown interior angle, and go ahead and find number 2, find the value of x. So do number 1 and 2 below. What kind of trapezoid is this guy right here? It is an isosceles. And I know that because its legs are congruent. So how many degrees is angle H? G? And F. Good. Find the value of x. How do I do that? So what is 10 plus 44? And then did you guys divide by 2x minus 1?
No.
Oh, to get the average. And then what is that? Sorry, guys. 27. Then I set 27 equal to? Good. And then I add 1 to both sides, so I get 28 equals 2x, right? And so what does x equal? Awesome. Questions on that? A lot of definitions today. Definition of a kite. A quadrilateral that has 2 pairs of consecutive congruent sides. However, opposite sides are not congruent. So do you guys see how a kite is drawn? And where my consecutive congruent sides are? Okay. How many degrees are in a kite again? 360. Definition of a right kite is a kite that contains at least 1 right angle. And so there's different spots where you could have this right angle. You could have it up top. You could have it on the side. So if you have it on the side, it would have to be on both sides for that to work, or on the bottom. Okay. A kite always has exactly 1 pair of congruent opposite angles. That 1 pair would come in between the 2 sides that are not equal. The angles formed by each non-congruent pair of sides are congruent. So they're saying that that's where your angles happen, in between the non-congruent sides. And then diagonals of a kite. Diagonals of a kite are perpendicular to one another always. So they will always create a 90-degree angle. So with that being said, I've also created 4 what inside this kite? Right triangles. And so is there a whole bunch of stuff we could do with right triangles at this point, guys? We could do Pythagorean theorem. We could use SOHCAHTOA. We could do 45, 45, 90. We could do 30, 60, 90. All that stuff that you've learned to deal with right triangles comes into play now, and they're going to expect that you remember that and can use that information on problems like this, okay? One diagonal of a kite bisects is 2 interior angles. So this angle is congruent to this angle. This angle is congruent to this angle. And then the last one is one diagonal of the kite bisects the other diagonal. So this piece is congruent to this piece. So what you've created is pairs of congruent right triangles. Do you guys see those pairs of congruent right triangles? These 2 are congruent right triangles. These 2 are congruent right triangles. Okay? Go ahead and do number 1 and number 2 down below. Let's look at number 1. How would I solve for x on number 1? Yeah, there we go. 2x equals 111. Because, remember, these angles are congruent to one another because they are in between the non-congruent sides. So divide by 2, and I get x equals how much? It's a decimal, and that's okay. There you go. How would I solve for y, then? Are these 2 angles congruent? No. I do know this is 111, though, over here. So how would I solve for y? Yep. So 360 minus that 80 plus 111 plus 111, right? Equals y. So how many degrees are left out of the 360 for that angle, essentially what we're doing. So how many degrees is that for y? Do you guys agree? Perfect. Okay, number 2. How did you guys find the outside lengths? What are we going to have to use on this guy? Pythagorean theorem, because this is a right triangle, right? So we're going to start with this WT and ST because those are going to be congruent lengths. So you just need to find one. So that's 3 squared plus 10 squared equals x squared. That's 9, and that's 109, right? It doesn't say what to round it to. Did I do that correctly? Yep. So it's square root of 109. That does not reduce down any. So if they ask for a reduced radical, that is your reduced radical. If they ask for a decimal, someone give that to me as a decimal to the nearest tenth, please. 109 is what? Okay. And then so this is 10.4 and this is 10.4. E to W and E to S are congruent also, so I just need to do one of those. So 3 squared plus 7 squared equals x squared. That's 9 plus 49, right? So that's 58. That may just be as reduced as it goes, I think, actually. Okay. And as a decimal, what is that congruent to? So this would be 7.6 and this is 7.6. Okay, perfect. Any questions on that information? I know that we keep adding more and more information into those quadrilaterals. Your homework and what you need to work on now would be the Schoology assignment. I'll open it up here in 1 second.